We'll be talking about urbanization and the soil sealing effect on a regional scale in the North America. And just like Diane, I'm also looking for contributions on papers and suggestions for researchers that I should mention in this presentation, in our publication. The overall goal for my part is to examine the status of soil sealing and urbanization effect on North American soils, and in the particular the last 10 years, since 2015 we'll do it. 2015, the European Commission established that the North America is shifting towards urbanization, and currently it's about 73.3% of the population residing in urban environments, indicating a significant migration or expansion towards cities and urban settings. A study done in 2020 found that half of all urban expansion occurred on forested land, signaling considerable conversion of this area into urban environments. This expansion also includes agricultural lands within urban-rural transition zones globally. Urban population densities, however, shows declining trend, especially in small to medium urban centers in North America, where densities decreased from 3,500 people per square kilometer to nearly about 500 people per square kilometer. This decline in population density also overlaps with urban expansion. It also indicates a sprawl pattern of the development where urban environments expanded outward, and it often at the cost of using natural resources and our ecosystem. Both North America and Europe exhibit consistently low levels of land use efficiency. According to the ratio of land consumption rate of population growth rate to population growth rate, which indicates it's an indicator designed to reflect many dimensions in the land use efficiency. So what are the consequences of urbanization? Can anyone tell me what urbanization is? I will ask you a couple of questions so you kind of wake up at the end of this talk. What is urbanization? How we define it? I'm not grading you, it's okay.
Population density.
Good. Any other insight? How else we can define it?
Infrastructure.
Good. What else? What else goes into it? What?
Soil sealing.
Soil sealing, good. So there are many ways how we can define, but indeed it's related to population density and the development of urban infrastructure. So direct consequences of urbanization include, one of them is land surface temperature. Conversion of natural environments to urban lands lead to a rise in land surface temperatures, of course, due to the increase of impervious surfaces, concrete, asphalt, which leads to reduction of water absorption capacity that elevates surface temperatures. Urbanization also diminishes the vegetation cover that leads to a rise in land surface temperature. Vegetation, naturally cools the land surface, so its reduction amplifies the warming effect. Scientists also observed shifts in the soil moisture availability due to land cover changes. Increasing impervious surfaces alter hydrological patterns, leading to decreased water infiltration, affecting soil moisture and surface wetness patterns. Biophysical parameter changes. Well, areas transition from cooler, more vegetated, and moist conditions to warmer, less vegetated, and dry conditions. And land use conversion, especially from forests to commercial areas, intensively alters land surface temperature and soil moisture. This change is even more pronounced than when it shifts from cultivated to residential lands. Talking about forest ecosystem services, there was a study done in 2 Florida watersheds when they were predicting what is going to happen within 57-year period. So they were looking at the effects of urbanization on carbon storage, timber value, and water yield. What they found in their projection that carbon storage potentially could decrease by 16 and 26% in these 2 watersheds by 2060, Carbon pools in 2060 are estimated to be 5% less than 2003 levels, and significant uncertainties would be related to forest carbon projections. However, there is a trade-off. Urbanization decreases carbon storage, timber volume, but it would increase water yield. So, soil sealing. What is soil sealing? Well, it's a byproduct of rapid urbanization. It involves coverage of natural land surfaces with impermeable materials. And here in St. Louis, we have a great example of what soil sealing looks like. What are the effects? It includes, of course, loss of land, agricultural land, reduction of water infiltration, alteration of hydrological cycle, loss of biodiversity, microclimate changes, soil degradation, and increase in pollution of air and water. Stormwater management is one of the issues, of course, associated with impervious surfaces. It's one of the challenges, especially now when we have more extreme events, when we have more often, frequent, and stronger rains. So urbanized basins were studied in the US, Northeast, and Midwest regions that demonstrated a substantial percentage of increases in peak flow magnitudes. This trend in these basins was significantly related, obviously, with the basin urbanization, implying a direct relationship between increased impervious surfaces and heightened peak flows. The inability of impervious surfaces, asphalt and concrete, to absorb water leads to faster flood conveyance through channelization, channel lineage, storm sewers, curb and gutter streets that further poses challenges in managing peak flows and preventing flooding during high precipitation events. The increase in impervious surfaces can also lead to elevated flood magnitudes due to rapid conveyance of water over the surfaces and through urban drainage systems. This poses not only challenges to manage peak flows, but also transport pollutant from surrounding areas to water bodies, and that eventually affect water quality and aquatic life. And one of the main emerging contaminants these days that we should really focus on is PFAS. We already know a lot about heavy metals, microplastics being studied more and more, but PFAS is becoming more popular in the studies, and more research comes out, and I think it would be important to include in this decadal publication. So any of you know what the PFAS is? Have you heard about PFAS? Can you raise a hand? Good. So can you tell me what PFAS are?
Forever chemicals.
Forever chemicals. What they make them forever? Why do we use them?
They make plastics strong.
Good. What else? They have multiple functions. What else?
They repel water and oil.
Good. What else? They used foam and firefight, right? Repellent water and oil. Use a lot of consumer products, and we'll use them in pans, in our kitchen supplies. So definitely we use them a lot, but now we find out that how dangerous it is for the environment and human health, and we should really focus on studying this and understanding how it transports in the environment and how we can mitigate the impact. Where we can find PFAS in soil? Can anyone tell me? Where does it accumulate? Or what are the sources that are related to soil of PFAS? Do we find them in agriculture fields? Do we find them in landfills? Do we find them where? Yeah, there are multiple sources, right? It's not a trick question, it's just bring all the knowledge together. So they come indeed from firefighter foams, it can come from contaminated sites, obviously, it can come from landfills where the products that can break down and release into the environment. The distribution is really widespread because PFAS can be transported in the air by water and reach really further large distances. And some of the PFAS actually come from biosolids because they come out even during water treatment facilities. So it's there, it's everywhere. And there was this interesting study that actually conducted a global survey, and they included North America here. They did all continents. They studied 32 PFAS types in surface soils, and 33 sites were in North America. So what they have a whole graph that shows different concentrations of this PFAS in different continents. But it was really interesting to see what they find in what concentration. So they've calculated quantifiable levels of PFCA observed in all the samples with total concentrations ranging between 29 to 14,000 picograms per gram of dry weight. Then they also calculated PFAS which were detected in all but one sample, goes up to 3,200 picograms per gram. The geometric mean of PFCA and PFAS concentrations were high in the northern hemisphere compared to the southern hemisphere. And the PFAA and PFOS were the most commonly detected analyzed with concentrations up to 26 and 3,100 picograms per gram. So what can we do about it? You're probably depressed by now, right? Like, oh my gosh, it's everywhere, we're going to die. So there are ways how we mitigate it. And lots of researchers are studying right now PFAS, and they find many different techniques. But overall, we need to look at our cities from a sustainable point of view and really include sustainability more and more in the urban planning, urban architecture. Of course, green infrastructure is one of the solutions. If we have more permeable pavements, green roofs, rain gardens, it will help to infiltrate more water, improve hydrology, and prevent those floods. We should include more wetlands and forests that could serve as buffers and filters for our environment. The development of stormwater retention bases and the integration of stormwater management practices should be integrated in urban design and urban planning, which leads to more policies and regulations that should require the incorporation of stormwater management practices in new developments that incentivize the retrofitting of existing developments. If you would like to read more about specific management practices for various air environments like parks, sports fields, schoolyards, recently we published with Maxine Levin an article, Encyclopedia of Soil, that goes really great detail on these practices. So you can use a QR code to get the article or ask me for a free copy. So what I also wanted to highlight while I was doing this research, and I hope you can help me to fix this gap, is I found there's really a lack of regional trends that I found in studies pertaining to North America. There were a lot of articles were published before 2015 or 2016, and a lot of articles in Europe and China related to urbanization and soil stealing, but not many regional studies for the North America. So I think it's really a great opportunity for PhD students, master students to maybe investigate this further. So, my contact information, if you'd like to stay in touch on social media or shoot me an email, I'll be happy to respond to any questions you have in the future. Thank you very much for your attention.